Hey, everybody. Sorry that you're all packed in here so much. I didn't really expect there to be this many people. So I'm glad you're all excited. Woo! Yay! Unite Day 2. If you're not hungover today, you will be tomorrow. So today I'm talking a little bit about procedural content generation in Unity. Just a little bit about myself so that you know that I'm not some guy who just wandered off the street randomly and started talking about stuff. My name is Chapin. I'm a client, I was a client, now I'm a server developer at Goodgame Studios. I have a bachelor's and a master's degree in computer science from Drexel University from Philadelphia. So, woo, Phillies. While I was over there, I also taught a lot of game developers, mostly Unity stuff, but all sorts of different things. I also am a fallen indie developer. I worked for a little while for myself. I also worked for a little while at a company called Cypher Prime Studios. And as an indie, that's sort of where my love of procedural content started. Because when you only have 2 or 3 people on a team, having the computer make stuff is a lot easier than having to do it all yourself. So that's why I'm here. I'm a procedural content enthusiast. I love doing PCG things. I love hearing about PCG things. And I really like sharing the gospel of procedural content generation. Just as a quick warning, we have 30 minutes to go through all of this. And I'm not going to be able to hit every single topic on PCG and Unity. So sorry, it's a big topic. What this presentation is basically going to be is the first part is going to be a quick introduction to what PCG is, what you can do with it, and sort of a few techniques that you can use to get those goals. And then the last 2 sections are a little bit more in-depth about how I implemented some PCG, solved some problems with procedural content generation in Unity. So really first, just a quick poll so I know what I can skip and what I shouldn't. Who here has no idea what PCG is even about? It's just a buzzword. OK, cool. So who spent a lot of time reading about PCG but hasn't really implemented anything using it in the past? Show of hands. Cool. This talk is mainly designed for you guys because you can read about stuff all over the place, but there's no substitute for actually seeing it in place. So who's consumed every single piece of media relating to PCG, including all of the past Unite presentations, up to and including the GDC presentation they just released with Tanya Short and the Dwarf Fortress guys? 1 guy. Awesome. All right, so this isn't going to be boring for everyone. That's important. So a quick intro to what procedural content generation is. The PCG Wiki, which is a really, really great resource if you're getting into procedural content generation, says that PCG is the programmatic generation of blah, 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 blah. Basically, it's using algorithms and data to make your content rather than having a designer or a 3D artist go through and do it all by hand. If you have a lot of content, or you have content that is going to be so huge that no human could ever fathomably complete it before your game ships, or before the heat death of the universe, PCG will actually let you solve those issues. So what can we procedurally generate? We know that we can, but what can we generate? Planets is super easy. It's kind of a rite of passage as someone who wants to get into PCGs to build your first planet generator. We can build dungeons, even if we go all the way back to NetHack, people have been generating dungeons procedurally. Back then, it was because they didn't have the memory to store static maps, and now we're doing it because it's more fun when it's different every time. We can procedurally generate guns. Borderlands got really famous for having its trillions and billions of guns by just slapping pieces together procedurally. We can generate puzzles. This is actually a diagram from the procedural generation subreddit, which is also a really good place to check out if this interests you. And what this guy did is he actually generated a lock and key puzzle, sort of like Doom, where you have to find the red key to unlock the red door, the blue key to unlock the blue door. But the way he set it up was so that he guarantees that there's not going to be a red key behind a red door, so you lock yourself out. And we can even go a little deeper and a little more interesting with it. We can start procedurally generating things like religions. This is a game called I totally lost it already. Dang, I feel really bad about that now. But this is a really incredible roguelike that's being developed. And every single thing in it is procedurally generated. What? I don't know. I'm sorry. But yeah, so everything in this game is procedurally generated, down to like the textures on headstones. That's all being done PCG. So, and as part of that, the game's religions are all being procedurally generated as well. We can procedurally generate enemies. This is a game called Inside a Starfilled Sky. I remember that one, where you can actually dive into the enemies, sort of Inception style, make changes inside of them, and then jump back out to change how they behave. We can procedurally generate animations. If you want to have something that looks a little bit more natural, we've actually been procedurally generating animations for a very, very long time. And in case you were keeping track of time from presentation start to the time Dwarf Fortress was mentioned, here it is. We can procedurally generate worlds from the ground up, starting with the formation of the universe and things like that. And there are a lot of people who are doing some really cool things with these techniques. We can build anything. There's a lot of different approaches to generating things. These are just a few examples of techniques and algorithms that are being used. Voronoi diagrams, we'll go over those in a little bit, but Markov chains, grammars, genetic algorithms. Yeah, this is one you might want to take a photo of. But really, at the end of the day, it's important to figure out what the input you're going to feed into your procedural system is and what sort of output you're looking for. Because based on what you're trying to generate, you might need just random numbers, or you might need a texture, or you might go full genetic and have a fitness function and your genotypes and your phenotypes. So you have to figure out what you're going to feed into that black box of procedural whatever. And then you also have to figure out what you want on the other side, what you want it to actually generate for you. Do you want it to generate a 3D model? Do you want it to do balancing values for you? Do you want to just come up with custom textures so that every single one of your weapons has a different skin? Or do you want to generate your custom 3,000-year-old planet? And PCG has been getting even more popular recently than in years past. And a lot of that has to do with the fact that each player gets a unique experience, theoretically, if you do your PCG correctly. So there's always more things to explore, more things to do. It extends the replayability of your game, and it also extends the streamability, the YouTube ability or Twitch ability of your game, which in today's ecosystem is pretty important. But from a very selfish side, PCG can also be used to save your designer's time. So like I mentioned before, rather than having to generate a million different things by hand and tweaking all those values manually, you can make a computer do it. That's what computers are good at doing. It can help you with scale, not just of quantity, but also of size. You can use PCG techniques to build worlds that are just far, far larger than something that could ever be hand-modeled, including the image at the bottom here. If you recognize it, it's the recently delayed No Man's Sky, where they procedurally generate an entire galaxy. As someone who shipped the game on the PS4, I'll tell you that they actually make you check a checkbox that says, I have reviewed all the content in that game, so I'm pretty sure that's what's holding them up. So we have all this power, and we have all these different techniques, and we have all these different ways of generating X using Y. But what's really important, and this is the quick word of warning that I give to you guys, is decide what in your game needs to be procedurally generated, and decide why. Because if you procedurally generate something, and you have a million different iterations, but all of those iterations really look the same, you run into an example. This recently happened in Fallout 4, where they have a character who procedurally generates quests for you. And people hated it, because all of the quests were so similar. Like, there was only minor variations each time. And I think inside of a week of that game being released, there were already mods to get this character to stop giving them quests. So I talked a little bit about what PCG is, so let's talk about something that PCG can do. One of the most popular applications that I've seen it being used for is procedural mesh generation. And that is kind of exactly what it sounds like. You build meshes procedurally rather than hand authoring them. So if you're building a normal game, you have a little house and you want to put a fence around that house. You might have your artist or your level designer or whoever is in charge of your scene, and they build a house. They build it out of posts and slats, and then it looks nice. It's good. But then later on you say, okay, maybe the terrain changed, or maybe it doesn't look quite right, so I need you to change it. And the artist or level designer goes back in, tweaks all the positions, makes sure everything looks right, and they're happy with it, and you move on. But then someone says, oh, no, the fence wouldn't look like that in real life. Maybe it has a different path. So then your artist level designer goes in again, changes everything, and they start getting a little upset with you for tweaking everything all the time. A procedural approach would be to build a sort of fence builder. So you have a little snippet of code here that takes a position for the post and sort of a next position for the next chunk, and you connect all this stuff automatically. So what you would do is, rather than having to build the entire fence by yourself, all you do is specify a path. And then you say to your fence builder, hey, here's a path, build me a fence, and then the robot goes and does it for you. And then the upside is that if you want to change your path and do something different, you just clear that away and say, OK, here's a new path. Set the robot on the path, and there it goes. It gives you your brand new fence. So now we're going to move to the demo. This was a demo that, as an American, I thought was very, very important. I wanted to make more money, so I decided that I wanted to build cars. But I didn't want to build cars by hand because that takes an engineering degree, and it's just such a hassle. So I decided to procedurally generate them. And to cover most of the widest swath of the market, I decided to generate anything between a smart car and a Chevy Suburban. So here we have my beautiful car here. And I have my little car generator script. And basically, what I can do is I can hit this new car button, and it's just randomly generating a height, a width, tire size, all that stuff based on parameters that I fed into it as part of that script. So you can see here that, just a bunch of random data, and I grabbed random numbers, and I generate these cars. So that's how I generate the parameters for it, but how does it actually build the mesh? This is something that's actually really easy to do in Unity, or at least it's easy to get started. Building cooler looking meshes than that takes a lot more time, but just sort of as a basic 101 mesh generation, you have a mesh class, and you give it a list of verts, you give it a list of triangles, you give it a list of normals, UVs, you take all of that, you put it together, you throw it into the mesh, and you're good to go. But you have to do it in a particular order. So you start with your vertices. And these are vector 3s. You just throw them into a list, and they get an index. And so you can see here's the rough vertex outline of what one of my cars would look like. The next thing you have to do is wind your triangles. And that's stored as a list of ints. Basically, it's, for this triangle, it's 0, 3, 1, which tells you, the triangle goes from 0 to 3, 3 to 1, 1 to 0. And one of the things that it's really easy to make mistakes on when you're getting started with this stuff is that you have to make sure that you wind your triangles properly. Because if you wind them in the opposite direction, everything's going to face the wrong direction. A really handy tip for making sure that you do that correctly is you give yourself a big thumbs up with your left hand. Because when you do that, your thumb is going to be pointing in the direction that you want the plane to face, and then your fingers are going to curl in the direction that your triangles should be wound in. So once you get that set up, you wind all of your triangles, and then if you paused at this point and looked at your model, you'd see a nice pink box. So what you need to do then is move on to setting up your UVs. Here's the texture that I used for my little car. You can see that you've got your windshields, you've got the lights here, and then you have the rear lights, and then you have the tire. So this is a texture. It starts off at 0, 0, and 1 to 1 in the UV coordinate space. And so if you have these particular coordinates, you get your window pane. What's really important to note is that right now, in this car, this little point here, this corner, actually has 3 different UV values. It has the 0.51, because right here it's the upper right-hand corner of the window. It has a value of 0.1, because it's the upper left-hand corner for this one. And then it actually also has a third value, 0.0, here for the roof. So one of the things that you really have to watch out for is that sometimes you'll have vertices that have multiple UV coordinates based on which triangle they're a part of. So if you're doing everything manually by hand, it's really easy to have to copy vertices and mess this stuff up. But one of the first things that I did when I started getting into PCG is write a simple little script where you just keep track of which vertices you have and how many different triangles it has with different UV coordinates. So little tip. I'd share that script, but it's garbage. I wrote it a while ago. But yeah, so for the rest of the car, you just specify the UV coordinates for the subsection of the texture that you want to display, and you map those UV coordinates to the vertices where they belong. So you got your front lights and you got your rear lights, and then down here in the lower right-hand side, you can see the section of the texture that's used for the tire. And I don't know about you, that doesn't really look like a tire to me. It's not circular. It has the gray and the black for the tire, but it's not, it doesn't look like a tire. But what we do is we actually use, when we're doing our mesh generation, is creating little sort of pizza pie slices and using these coordinates here, and then we build the mesh in such a way where that one center point here, the 0.50, is reused everywhere. So you can actually get a lot of extra space out of your UV textures by paying attention to how they're going to be used. Talking too much. I need to get some water. So you're all Unity developers. We're building a bunch of brand new objects. It's really cool. But I don't know about you guys, but I started off as a mobile developer, and I know that it's very, very important that you not blow out your draw call count. And when you're generating a bunch of random things based on a bunch of parameters, it's really easy to do that. So it's one word to the wise is to make sure that when you're building these things procedurally, that you keep an eye on that, at least if you're on mobile. And you can actually have Unity dynamically batch these things into a single draw call if they share the same material. So like I showed before with the texture, all of those cars shared the same texture. If I wanted to have different colored cars, I could probably change the shader that I was using and use vertex colors if I wanted. If they have the same transform scale, so normally I just set all of my stuff to be 111. And then if you want to create size variations, you do that in the vertices themselves rather than trying to manually scale things up or down. And then the third thing is kind of, it's a bit trickier. You can only dynamically batch things if they adhere to a certain vertex attribute count. It's not vertices, but it's the number of attributes that the vertices have. If you have a normal position, a normal value, and a UV value, you can batch about 300 verts at a time. So if you're building huge multi-million poly objects dynamically, they're not going to batch. Sorry. Maybe you shouldn't do that on mobile. And one of the other really handy things that Unity provides you that really helps out PCG content, that really helps PCG designers is editor scripting. A lot of PCG stuff is best done before the game even starts. It doesn't need to be done at runtime. You can build really good editor tools that allow your designers to build their content faster and easier. So going back to this example really quickly, I've got a bunch of cars, and maybe that one, I like that one. It's a nice little like stretch Lincoln or something. If I actually wanted to save this model, I have an editor script here that overrides my inspector. So I click Save Model, and it's mad because I duplicated it. But you can see here that it's saved that model out, and later on, if I go through a few more cars and decide, no, I really just like that car that I made a while ago, I can go back and save that. I've saved that now as an asset. I can throw that into my version control, and I can use that later on in the game. So if you're not super familiar with editor scripting and you want to get into PCG, I highly recommend doing it. It really sort of opens up your realm of possibilities with regards to Unity. There are two sort of main ways to get into editor scripting. You either create a custom inspector so that when you click on an object in your hierarchy or in your scene view, in the inspector, instead of seeing the default Unity UI, you can actually customize how that looks and add custom buttons and things like that. Or if you're trying to build something that's slightly more than just one script, what you can do is you can actually create an entirely new custom editor window that actually shows up in your top bar of Unity, so you can set things up however you want and generate meshes, generate worlds, whatever you want. It's great. And while we're talking about mesh generation, this is actually one of the most common uses of procedural generation, which is generating meshes or terrain. Building huge worlds that look realistic or less realistic depending on what you want. And it's actually really easy to do that in Unity too, because it's just a mesh. So you can either build your terrain as a totally, a normal mesh. You can just build it, generate your height maps, build your caves, do holes or whatever you want, but you don't really get the benefit of the Unity terrain system. If you want to use the Unity terrain system, that's great too. You just have to be aware that there are some limitations with the terrain system that Unity gives you. But at the end of the day, you're generating points, you're throwing them into an object, and then it's spitting out something that looks like this. And while we're talking about building worlds and building maps, I really feel like it's important to mention the Voronoi diagram, because this is a very, very commonly used technique. Voronoi diagram basically is it's an image, but it shows you some very interesting things. So you start off with a totally blank field, and you generate a bunch of random numbers, or a bunch of random positions here. So you can see these are just some points. And then you run the Voronoi algorithm over it, and you get a post-impressionistic painting like this, which sort of segments everything up into different areas. So if you wanted to build like a strategy game or something that has biomes or things like that, you get something like that, which separates the area into smaller sub-areas. The problem is that doesn't really look very natural. It's sort of weird and jagged. But what we have is another great algorithm called a Lloyd relaxation. So here on the right, this is a Voronoi diagram that was a few more points were generated here. And what we can do is run that Lloyd relaxation over this diagram. And then the resulting diagram is much more uniform, but still has that very naturalistic looking shape. Everything's a little bit closer in scale, but they're not identical. It's good, but it's not perfect squares, because then that would be boring. So you can generate things that look like this. This is from Amit Patel's Red Blob game site, which is actually a really good resource if you're looking into PCG stuff as well. And this is how he built this island using these techniques. So he started off with the Voronoi diagram, the Lloyd relaxation, and then he also used something called the Delaunay triangulation, which is basically just for creating links between all of the little cells in his map. So the next thing he did is he started off at the corners and worked inward, just raising the height of each of those individual points. So at some point you cross sea level, and then you get the outline of your island. And as you go closer and closer into the island, it gets higher and higher, which is pretty close to how islands are actually built. So it looks pretty close to realism. The next thing he did was calculate water flow, and since everything was moving up as it went inward, it's really easy because water always flows down. But that was really important because the next thing he uses is something called a Whittaker diagram. And what that does is that shows you, with the average temperature of your area and the amount of precipitation, what sort of biome that you get, whether it's a beach or whether it's tundra or whether it's a forest. So with the temperature information and the precipitation information and the height information, then you generate all of the biomes that exist in your island. So now you have something that looks pretty natural and makes sense based on the laws of ecology or natural world. So then you've got that, and then all you really have to do then is add some noise, make it a little bit pretty, and boom, you've got yourself an island that looks like you could have found it on Google Maps. So that's one way that you can do level generation. It's less Unity-focused. It's just sort of a higher-level way of doing things. But there's one particular thing that Unity does really well that lends itself to procedural level generation. I mean, we have games like Minecraft. We have the Voronoi diagram example from before. You have things like Dwarf Fortress where they're generated at the individual tile level based on some algorithm. But maybe that's not exactly what your game is looking for. Maybe your game is like a puzzle game, or maybe your game takes place inside of a building, and generating things at the 1x1 meter scale is just not going to do it for you. This is a game where the levels were procedurally generated, but you can see that the player here is in this map, but these yellow dots, which are his goals, are not reachable. So you need something that is better than that. And that's chunks. There a lot of games use this technique where instead of building everything in the level from the ground up every single time, you have chunks that are built by designers, tested by designers, and verified within a certain levels of making sure that everything works, and then they throw that all into a library of chunks, and then when the game needs a new piece of a level, instead of generating everything from scratch, it says, okay, I have these many parameters that match, I need to throw something in here, so I can either put this chunk in here, or I could put that chunk in there, or I could put that chunk in there. And what's really nice is that if you're a Unity developer, you know that these could easily be different prefabs or different scenes that you just throw into your level generator and you move on with your life. And this is actually an incredibly common technique for games that use PCG level generation, because it's really hard to make sure that something looks good every single time when it's randomly generated. So if you know that all of the individual chunks are good, and you know that the algorithm that stitches them together are good, then you know that everything's going to mesh well. There's a lot of games that use this technique, like Spelunky and Binding of Isaac and a million more, including XCOM 2, which originally tried with XCOM 1, the reboot, they tried to do a completely PCG approach, but found that it was generating too many situations where the player couldn't actually win or reach their objective. So they threw it out in XCOM 1. In XCOM 2, they tried something that they called a plot and parcel system, where they had 3 different chunk sizes, large, medium, and small, and they'd have a grid like this, and they'd start putting their pieces down. So here we have the start and the end, and then you grab a few large chunks, a few medium chunks, a few small chunks, and you throw them onto the map, and they're guaranteed to not overlap, so you don't have to worry about them causing problems. Then after that, you build the roads or the pathways that the player might follow. So then you get your roads, and now you have sort of the nice little level layout that looks like it could have been designed by hand because all of the individual pieces were. And once you have all that set up, then you can throw sort of a light dusting of randomness over it, where you generate cars and objects that aren't really going to make that big of a difference and have a lower chance of actually breaking everything. So you get the unique look, but you don't have to worry about your placing a dump truck right in front of the exit extraction point or something like that. So once you have all that, the level's built, the player goes in, boom, they get hit by a muton, and they regenerate a new level for them later on. Just a few more other possibilities. So these are 2 very drastically different approaches to building levels. The one on the left is Nuclear Throne. The way it works is it starts with a totally filled-in field. It drops a walker where the player spawns and just sort of has it randomly either go forward, turn left, or turn right, and drop rooms. And it's an incredibly simple way to do level generation, but it works. It works for their game. It works for their gameplay. So that's great. If you're trying to build something like a maze, you probably wouldn't want to do that because you have no real guarantee that you're going to get your branching paths or anything like that. So you can use, instead, this technique called recursive subdivision, where you take your area, split it up into a couple smaller chunks, open up holes between those chunks, and then recurse on that smaller area. And that's one way to guarantee that you get a maze that is solvable, is doable, and actually looks like a maze. So for the little car example that I had, I had my cars, but I didn't really have anything to test them on. So I wanted to build something where I could test my cars. So what I have is a track generator. And what this does is it builds sort of a looping track, sort of NASCAR style. And none of the techniques that I mentioned before would really help. Because it's not a maze, it has to loop, which is really important, and I don't have to worry about mutons, so I don't have to. The XCOM 2 approach isn't really going to help me. So what I did is I set this demo up, and what it does is it takes in. It creates a bunch of squares and places them at the center and moves them around each other so that they're always connecting. And then once I've done that a few times randomly, it'll just go through and finds the start point and walks all the way around the outside, which means that it's guaranteed to be a loop because all of these squares touch each other. And it means that the shape that I get, doesn't look like a Formula 1 track, but it's pretty close. So if I maximize this, I've got my new little track, I got my randomly generated car, and boom, I am driving around. And my laptop is dying. Cool. So this was actually a technique that I came up with based on a problem that I saw another procedurally generated designer had with their roguelike levels, where they would generate a bunch of these squares on top of each other and then push them all out to keep them separated, because that's what they needed for their design. But for my design, I needed the exact opposite. I needed all of these shapes to be intersecting. So who knew that if the output that you wanted was a looping track, the input that you needed to provide it was a bunch of random squares, or rectangles, I guess. So it's just really important that when you're designing the content that you want, that you think about, again, what sort of input you want to throw into it and what makes the most amount of sense. And I'm basically out of time, but that's OK, because I'm basically out of content. Just two quick tools that I wanted to mention. If there's not a whole lot of PCG tools that are super available, but SpeedTree is a really popular one with larger designers. Basically, it's for building trees procedurally. This other one, Celix, is a relatively new tool that's been just released that tries to build things procedurally using a node-based system. I can't say if it's great or if it's not great. Basically, I got about 5 minutes of playtime into it before I had to get out to Amsterdam. So, but it looks very promising. So I definitely recommend checking it out. And I'm over time, so we're not going to talk about the issues with PCG. Basically, the biggest problem is making sure that everything's unique. Here's a bunch of resources. And in particular, if the procedural mesh generation interested you, there's actually a talk here tomorrow. No, sorry, it's in track 2, called The Power of Procedural Messages by Alexander Burke. He has a lot more time than I do, so hopefully he'll get all of the questions answered about that. I am way over time, so thank you for your attention. I hope it was illuminating.